Hi everyone. In this video I'm going to work through a second example problem of solving trig equations. What I would encourage right now is if you don't have a unit circle on hand, I have one on the next screen, go ahead quickly Google one or pull one up from the Google Classroom, that Google Classroom document or assignment or material that's already been provided. A second note is I would strongly encourage you to pause the video right now and try and solve this equation and see how far you can get. Because one of two things will happen. You'll get the solution and you'll verify that it's correct, or you'll hit some dead end and you'll realize what needs to happen to continue moving forward. So go ahead and do that if you haven't. All right, so getting into this, cosine of x minus 1 equals 0, and we have some domain restriction from negative 2 pi to positive 2 pi. All this tells us is I can't put an x value of like 5 pi into this, or we don't really want to consider those. Because trig functions oscillate, like a cosine function goes like this over and over and over and over and over, what we're doing here by putting this domain restriction is we're saying we're only going this far to the right, or we're only going this far to the left. So we only want to know where it achieves certain values within this range, or this domain, I should say, this span of x values. So that's all we're doing there, is we're making sure we don't have an infinite number of solutions. So with most equations, we want to isolate the x. Well, we're taking cosine of x, so we want to isolate cosine of x, or the function here. So we do that by adding 1 to both sides. So if we take cosine of x and we add 1 to both sides, we get cosine of x is 1. So we want to find what values between negative 2 pi and positive 2 pi I need to take the cosine of to achieve or receive a value of 1. So going to our unit circle, when we're thinking cosine, we're thinking x values here. So on my unit circle, I'm going to identify all of the values in radians, because our domain was in radians, not degrees, that have a x value of 1. And right now there's an x value of 1. So 0 is one of our solutions. Now as we work our way around, I'm looking for x values of 1. That x value is 0. That x value is negative 1. This x value is 0. So there's only one time it actually happens. But if you take note, I made it all the way around the unit circle, so I actually went 0. Where I started, it happened to be that value, and then all the way around I went 2 pi, and I achieved that as well. So there's two values right now that we can think about. So if we go back to this, cosine of x equals 1 at x values of 0 and at x values of 2 pi. So right there I was thinking of a domain between 0 and 2 pi. So when I went one revolution around the unit circle, I thought of x values between 0 and 2 pi. So I've considered part of our domain, but not all of it. So now when we start thinking about the negative end, we're actually going in a clockwise direction around the unit circle, and we're counting in increments of negative pi halves, or negative pi fourths, or negative pi sixths. So if we go back to our, that's the other way. If we go back to our unit circle, and I erase this, if I start here, that's 0. I already counted that one. And now I'm going in the opposite way that we normally rotate, which is clockwise. We normally go counterclockwise around the unit circle. So at 0, we already did that. We're good. And this is negative pi halves. This would be negative pi. This would be negative 3 pi halves. And then negative 2 pi, I hit it again. So at negative 2 pi, I achieved a x value of 0 as well. This would be considering the values to the left of the y-axis when we're graphing a cosine. So that would be values like right here, it's at 1 as well. So this would be negative 2 pi. So there's actually 1, 2, 3 values that satisfy this requirement. Oh, wrong way again. And those 3 values are x is 0, x is 2 pi, and x is negative 2 pi, because we have that opposite, that negative world of radians open as well. So we would say cosine of x minus 1 equals 0, which was the actual equation we were set out to solve, for x values of negative 2 pi, for x values of 0, and x values of 2 pi. There are other ways to consider this by adding 2 pi and whatnot, but I really wanted to look at the unit circle and just a solid way of working through this for the given domain. As we make this domain larger and larger and larger, we can consider other strategies for solving this. So look for that in the next video to come. I hope this helped. Post questions in Google Classroom. Let me know what I can do to help as well.